Hello, today's notes are about factoring polynomials using the AC method. Your essential question for this set of notes: when using the AC method, what do the two numbers have to do in order to get to the top value placed on the x and the bottom value placed on the x? That'll make sense in a second. So terms and definitions to go over before we start doing examples. Your first term is a coefficient. This is a factor, usually a number, that is being multiplied by a variable. This is also known as the number in front of the variable. So if we were to have our polynomial here of x squared plus 3x plus 5, then what we would actually see is that the numbers in front of the variable, so my variables are here and here. So what are the coefficients? Well, that number 3 is definitely the coefficient, and there's a little invisible 1 right here that is actually the coefficient as well. So these are both coefficients. And I just wanted to point those out that we only are actually going to be using the numbers. So 1 and 3 would only be the coefficient. Our next term is constant. This is a number that's by itself. So if we have our polynomial again, x squared plus 3x plus 5, then the only number that's by itself without those variables is the 5 right here. So that's our actual constant, number 5. Our last term, factoring. This is the process of separating a polynomial back into a product. We will be going over like 4 examples in this about factoring, but I just want to let you guys know that a polynomial that cannot be factored are actually called prime. So if you are not able to factor like anything, you can't even take a GCF out, then it's just going to be prime. Okay, so just a reminder, before we do all of this, we have to make sure that our polynomials are in standard form, which means that we are going from the greatest exponent all the way down to the lowest exponent. So our values are listed our highest exponent all the way down to our lowest exponent. In order to do this, you have to be in standard form. The reason being is because then we have to know which value is going to be our A, our B, and our C. And our A is always going to be with that x squared, our B is always going to be with the x term, and our C is always going to be the constant, the number by itself. So let's write down the steps on how to use the AC method to factor. So our step 1, your polynomial is in standard form and simplify completely. So make sure it's in that greatest exponent all the way down to the lowest exponent. Step 2, you're going to identify the GCF. We always identify the GCF no matter what in the when we are factoring anyways. Step 3, you have to identify values A, B, and C. Step 4, multiply values A and C. Place this value in the top part of the x. So we're going to be writing these little x's. That's when we multiply our A and our C term, you're going to actually go ahead and place on the top of the x. Step 5 is the B value, and that's going to go in the bottom part of our x, so that's going to get placed there. Step 6, you're going to identify two numbers that when multiplied together equal the top value of the x. So I'm going to have to try and figure out two numbers that I'm going to be placing here and here that will multiply to this top number. Then I also have to figure out those same two numbers have to add to that bottom value. So I'll be showing you guys this example. Step 7, these are your new b values. You're going to rewrite the polynomial using the new b values. Step 8, you're going to factor by group. Step 9, you're going to check your answer by using the distributive property, and you should always get back to your original polynomial in order to make sure that you did this right. Please don't force this step, you guys. This is to help you know if you did it right or wrong. So number 10, slide 10, I just want to show you guys what I was meaning by multiplying and everything. So what I mean by this is actually just side work that we're going to be doing on this side of our examples to help us factor. So our A, B, and C terms, we are in standard form. So we are going to be able to identify our A and our C. So whatever value this is, we're going to multiply A times C, and whatever the number that gets goes up here. Then our B value gets brought down here. Okay. Then we have to figure out what two numbers, so these little question marks right here, we have to figure out two numbers that when multiply are going to equal our AC, this top number here. We also have to figure out these same two numbers when added together have to add up to our B value. So that's all written right here, you guys. I'm going to erase this so that you guys can see a clearer picture of this. So go ahead and write down this part right here, this whole thing. Oops. So go ahead and write that whole box down just so you guys have an example of what to remember, because the hardest thing is remembering what to add or multiply those numbers to. For our first example is x squared plus 7x plus 10. So our very first step was to make sure that our polynomial was in standard form. So we are making sure that we've simplified everything. So we do have our highest exponent going down to our lowest exponent, so we are in standard form. Now we're going to go through and figure out a GCF. I actually don't have a GCF here, so I get to skip number 2 because I don't have any numbers, step number 2, because I don't have any numbers that go into all 3 terms, or I don't have a variable in all 3 terms. So now I'm going to go to step number 3. So if we look at step number 3, we are going to identify our A, B, and C values, and then step 4, we're going to multiply our AC and then bring down our B value. So let's go through and do that. This is going to be side work over here. So we're going to just draw our X over here, and then we are going to figure out, so A term, let's write our side work over here. So we have A equals 1, B equals, so remember your invisible 1, we're only writing the numbers 7, and C equals 10. So those are all my numbers. I identified my A, B, and C. That was step 3. Now I'm going to take my A and my C and I'm going to multiply them together to get my top value in the little x. So 10 times 1 is 10. So all I did up there was 10 times 1 and got 10. And then my B value I just bring down and actually write there. So now my next step is to figure out what 2 numbers, I'm going to put my numbers here, what 2 numbers are going to multiply to 10 but then add to 7. So we need to figure out all of our factors of 10. So if we kind of just break this down, you guys are going to get better at this. I know 5 and 2 works. Oh, and 5 and 2 probably is it, because 5 plus 2 is 7. 5 times 2 is 10. But you have to be careful because they can also be negatives. A negative 5 times negative 2 is a positive 10. But when we were adding those together, we would actually get a negative 7, and we want a positive 1. So this will not actually work. So I'm going to go ahead and use these factors, those numbers. So 5 and 2, just double check, 5 times 2 is 10, perfect. 5 plus 2 is 7. Awesome, we found my new B values. So now my next step is to go ahead and rewrite that. So I'm going to go through and rewrite our polynomial. We are going to rewrite it so we have 4 terms. So you always bring down your first term, that x squared. But now we're going to use our new B values. So it was a positive 5. It doesn't actually matter if you guys write a 2 there instead. You always bring down the variable that your B value was. So this is getting split up into our new B values. Oh, sorry, that should be a 2. So this is a 5x and a 2x now. So we just made, so if you guys can see, if we add 5x and 2x, we get back to our 7x. So perfect, we're just splitting it up, we're rewriting it. And then now you always bring down that 10, or the constant, so now I have a positive 10. Okay, so now we just start factor by grouping, which is what you guys were doing in the last set of notes. So we get to go factor by grouping. We're going to take the GCF of the first 2 terms. I see that I have an x in both, so x is my GCF there, and then x plus 5 is my remainder here. Here I have a positive 2 that I have as my GCF, and then I have an x plus 5 left over. Double check that you did your factor by grouping correctly. Then the values inside those parentheses are the same, so yes, that is one of our factors then. And that also means we did our factor by grouping correctly. And then the GCFs, the x and the plus 2, that is your other factor. It doesn't matter if you guys were to write x plus 5 there or x plus 2 there. As long as you have them, that it is being multiplied, so you guys, this is your final answer. Okay, so our next example is 21 plus x squared minus 10x. So first of all, our very first step is to make sure it's in standard form. Well, I see that we have our number by itself here, so that is not in standard form. We need to make sure we carry those values with the actual sign that it is. So it's a plus x squared, so I'm going to keep it a positive x squared. Then we go down to that negative 10x, make sure you have the negative. and then this is a positive 21. So make sure you're rewriting it with the correct signs. Great, so now we have it in standard form. Let's double check that we have a GCF anywhere. I don't see a numerical GCF, and I don't see a variable because the variable is not in the 21. So then I'm going to go to my next step. Identify your A's, B's, and C's. So this is where our side work begins. Go ahead and do your X over here, and we're going to identify A, that invisible number of 1 again, your B, which is a negative 10, and then C, which is 21. Okay, so now we're going to multiply A times C, because that's always what goes up here, A times C, and then our B value is down here. A times C, 21 times 1, 21, and then our B value is that negative 10. So I'm trying to figure out what two numbers equal, when multiplied, get you 21, but then add to negative 10. So that's the tricky part. So I'm just going to kind of write out some values. So 21, we have, 7 and 3. So 7 times 3 is 21, but 7 plus 3 is a positive 10. So how can we get a negative 10? So let's try that negative trick. Negative 3 and negative 7. Negative times a negative is a positive 21, so good. And then that negative 7 plus 3 more negatives actually does get us to that negative 10. So awesome. These are my factors I'm going to write. These are my new B values that I'm going to rewrite this 10 right here. Okay, so again, you always bring down that x squared. You're always going to bring down your first term and your last term. So first term, and then bring down your last term. Then we're going to rewrite the B value with the new B values that we came up with right there. So negative 7x, always bring your variable down. That was with the B value. And then we have a negative 3x. This was a plus 21. And then we're right back to factor by grouping again. So GCF of my first two terms, x, and then x minus 7. GCF of my last two terms. Remember, your leading coefficient's a negative, so you do have to take out that negative 3. And then it's the remainder is x, and then you have a positive divided by negative, so this is now negative 7. So we did our factor by grouping correctly. We got the same values in that parentheses, so that means that that is our one factor. And then you take your GCFs of x minus 3, and that is our other factor. We have factored completely. Okay. I'm going to go ahead and erase this so you guys can see that we are that we have gone through and actually checked our work too, making sure that we're doing this right. So I'm going to check my work over here now. So when we check our work, we are going to use this value first, our answer. So if we have x minus 7 times x minus 3, you're just multiplying. You're just distributing x times x, x squared, x times negative 3, negative 3x, negative 7 times x, negative 7x, and then negative 7 times a negative 3 is a positive 21. Combine like terms, those are the only terms that we get to combine. See how we are kind of going backwards? This is actually this step right here. So it's pretty awesome. You can make sure you're doing it right. So then we combine those terms and we get an x squared and we get negative 10x plus 21. And look what happened. That was actually our polynomial in standard form. So check. We are factoring this actually correctly. Our next example for this, so if we have our 2x squared plus 7x plus 3, this is awesome. It's actually already in standard form for us. So we're going to go ahead and write our x over here. So and identify our a's, b's, and c's. So a is 2. B is 7, and C is 3. Multiply your A times C. 3 times 2 is 6. Your B value is 7. So what multiplies to 6 but adds to 7? We got 3 and 2. If we add 3 plus 2, that's only 5. Well, how about 1 times 6? 6 plus 1 would be 7. So these are my factors I'm going to use, 1 and 6. And now I get to rewrite my b values. You're going to go ahead and bring down your first term, 2x squared. Rewrite your b values with your new b values. So plus 1x, you don't have to write that 1 in front of there, plus 6x, and then bring down that last term, plus 3. Identify, we see how we have 4 terms, so you're going to identify your GCF. So we have only an x as our GCF for the first two terms, 2x plus 1 left over. Identify your GCF for your last two terms. We have a positive 3 that we are taking out of there, so it's going to be a 2x plus 1. Again, we identified our GCF correctly and factored by grouping correctly. So our first polynomial factor is 2x plus 1 squared, or 2x plus 1, and then x plus 3 is our GCFs in our other factor. So if we were to go through and actually distribute this, then we would see that we have the correct answer again. So for this one, we're going to now multiply, so 2x plus 1 times x plus 3. Go ahead and distribute 2x times x, 2x squared. 2x times 3 is a 6x. 1 times x is just an x, and then 1 times 3 is 3. Combine like terms, so you get 2x squared plus 7x plus 3. Yay, we got back to our right answer, so check, we got it right. Alright, our last example, you guys. So for this example number 4, we have a negative 2x minus 4x squared plus 2. It is not in standard form, so go ahead and put that in standard form there, minus 2x plus 2. So now I am going from greatest to least on our exponents, and we are now going to do our side work over here. Identify our a, which is negative 4, our b, negative 2, and our c is 2. Go ahead and multiply a times c, so negative 4 times 2, which is a negative 8, and then our b value is the negative 2. Okay, so then now we are trying to figure out two numbers that when multiplied get us to negative 8, but when added get us to negative 2. So what two values can we actually figure that out? So negative 8, let's break that down. We know that 4 and 2, when multiplied, will get us 8, but we need a negative 8. So which one has to be negative, especially if we add it, wants to be negative 2. So we need more negatives than we do positives. Well, 4 is my higher number, so I am going to make that one my higher one. Now negative 4 times 2, that should be negative 8, and then negative 4 plus 2 gets us our negative 2. Awesome, so we found our new b values, the negative 4 and then 2. We're going to use those to rewrite our b value right there. So go ahead and bring down your actual a value, so negative 4x squared, and then now we're rewriting our new b values with the values that we got from here. So I have a negative 4x, a positive 2x, and then bring down that positive 2. Okay, so 4, I'm just making it the same color, so we know that was from my original equation. Okay, so then now we just go through and we do our factor, you can take out a GCF or you could just do factor by grouping. So here we do have a GCF of 2, but we'll take it out at the end too. So here your first two terms, we actually have a negative 4 and an x that we get to take out. So then we have an x, and then negative divided by negative is a positive 1. Make sure that it's not 0, you guys. Negative 4x divided by negative 4x is not 0, it's actually 1. So make sure you're putting that 1 there. Identify your GCF of the last two terms, so plus 2, and then I have an x plus 1 here. Awesome, we did our factor by grouping correctly. And then let's look at our GCFs here, our other factor. So we have negative 4x plus 2. There is a GCF there that we have to take out. And then x plus 1 is our other factor. You guys could have taken out the GCF back here in this step, which actually we probably should start getting used to, because then you have to end up taking it out down here. So our last GCF, if we take that out, is a 2. So then we have a negative 2 actually also, because that highest value of that x is a negative. So negative 2, that's our GCF. The remainder that we have is a positive 2x and a negative 1. And then we rewrite our last factor, which is just x plus 1, and then that is our final solution there. Okay, so then I'm just going to show you guys how to check that one again, just to show, because it's a little bit different. It has that GCF out in front of it, and that is our last thing. So go ahead and check our work. We have our negative 2 times 2x minus 1, and then x plus 1. So negative 2 gets distributed. That becomes a negative 4x Negative 2 to negative 1 is a positive 2. Put parentheses around that whole thing because now we're going to multiply it by that last term. Negative 4x times x is a negative 4x squared. Negative 4x plus 1 times 1 is a negative 4x. 2 times x, 2x, and then 2 times 1 is plus 2. Squeezing it in there. Okay, and then you have negative 4 plus 2x. We're combining like terms, so you have a negative 4x squared. Combine those, you get a negative 2x plus 2. And that is what we happen to have in our standard form. So check, we did it right.